I'm very glad to be here, and indeed I joined since the 23rd of January this year. And so it's fairly recent, and it's interesting to see how my career sort of came full circle, because about 33 years ago I started at IBM as a developer. I didn't do that for very long. I'm not very good at it, even though I still do it today. And through here at SIG, I've learned that I have a heck of a lot to learn, because I'm not really that good at it at all, but I like it and I enjoy it. But joining SIG in January had a reason. I like to work with people who are incredibly clever, and people here are. This is a profound group of people who have, over the 23 years of its existence, have cobbled together an amount of knowledge and tools that is phenomenal, and it's extremely well liked by our clients, and that is something I like very much too. That clients really like to see us coming and talk to them and give them this proper advice. There is something that happened about 6 years ago, 5-6 years ago, which is that we moved all of these tools into a platform. And that platform is called SIG, and it's this platform that we can now scale so that we can give this incredible value into the hands of so many more customers. Because if you think about it, we have hundreds of customers, but there is really no reason why that shouldn't be thousands of customers or even tens of thousands. And that's not ridiculous. This value is really that significant. It's up to us to really go there, and that is the sort of drive that I have. Tens of thousands is maybe a bit much in the next couple of years, but 1,000 plus should certainly be possible. So that is the mission for me, and the mission that we collectively are on with this team. And you called it our mission. I have this other sentence that I really like: creating tomorrow with future fit software. So this is your tomorrow, our clients' tomorrow, whether in whatever shape or form, with future fit software. So what are the characteristics of that software? What do you need to do in order to do that in a way that it is fast? You can bring new products to market faster, and you bring them to market securely and safely, and that is the task that we have on our hands. So I'm incredibly proud that I can join this team and that I can do the kickoff of this symposium, because this is when we give back to the industry, to you as our clients. What have we learned over the last year from that huge benchmark that we have cobbled together over the years? All these insights, we share them back to you so that you can bring them to your benefit. And there are some very interesting learnings, because I had the luxury, of course, to read the report before we were here, and it's a really cool report. So let us look to, and that was me, the introduction of the CEO. So the topics in this edition are 5, and I have them actually here. So the first one is about the benchmark and how the quality in that benchmark increased over the last year. We've been tracking this ever since, I think, 2005 at least, but for the last 4 or 5 years in this new model with SIG as the underpinning of that SaaS platform. There are a couple of trends lines. I think there are 6 that we will show to you, and that we use to show the improvement on quality in that benchmark. And there are some interesting findings in what you will see. At the architecture level, that is relatively new. We have decided to go after the enterprise architect as a persona, whom we think is a really interesting conduit to bring our tools and our platform into the clients we serve. And in this architecture quality model is relatively new. Next is AI and big data. There are some profound findings there. You will see them in a minute, but let me give you one first glimpse. So we give ratings, and we give 5-star ratings, or 1 to 5-star ratings, to the quality of the systems that we look at. And what you find in these systems, that there are a couple, because it's relatively new, these AI and big data systems, a couple are really at the 5-star spectrum, but there is way, way more at a very low level of that spectrum, 1 to 2 stars. Well, we'll talk about why we think that happens. On open source, we discussed that already last year. We introduced it as a topic, an important topic, because there is so much of open source that large enterprises use, but they don't necessarily keep it very much up to date. And that is a problem, because it is an enormous vulnerability potentially, something to be looked at. And then lastly, this is new. If you think about the holy trinity in our industry of people, process, and technology, then we look at process and technology as SIG already. But looking at the people, maybe a little less. And for that, we have worked together with Exin, our sister, because they have some very interesting findings on the combination of skills and the job roles that people have, and are those skills up to snuff for the future that we are collectively going after. So with that, without further ado, I'd like to give the word to Magiel, but not before I tell you that there's something special about that picture. And Magiel will tell you why. Thank you, and thank you for those online for joining us. Thank you for your time. This is the time for us to give back, and I know that we will make it very much worth your while. There we go. To you.
Thank you. All right. Well, let's see it then. Here it is, our benchmark report for this year. It's an incredible team effort, I have to say. We work with a record number of 11 authors within SIG for several months on this, and I'm really happy on how it came out. But we cannot give it to you today in this form, unfortunately, because we did find one mistake we cannot live with, and we have to correct it. So you'll get it before you go on holiday, but not today. There will be a digital version, of course. Still, the contents are very nice. I will walk you through the 5 chapters that Bart just outlined and tell you the highlights. There's a lot of content in here that I think you should process at your leisure and with some reflection. But I should now talk about the picture. AI, right, is a thing. So we thought, let's see how far we get. So all the artwork that you find in this book is generated with AI. And by itself, that is pretty hard to spot nowadays. It's not impossible. There's always some hints that it might not be real. So we put prompts. So what you need to put in the AI algorithm to sort of get what you want. And so you will see that. Maybe next year, AI can do the entire job for us. We don't know. Let's see. Let's get into the meat of it then. SIG does software consulting for which we measure source code. That is really at the core of what we do. Our clients trust us to send their code to us on a weekly basis, on a daily basis, maybe even on an hourly basis. And that adds up to our knowledge base of measurements and code that we have in store and that we can use to do research. So this was the situation last year, already quite an impressive series of figures. And this year, we've grown substantially. All the numbers here, the number of systems measured, we were incredibly happy when we hit the 10,000 systems measured. We bought a big Lego set of 10,000 pieces that is now in our office, the Eiffel Tower. But we went above and beyond that very quickly. So this gives us a very rich database to do research with that my team is really enjoying to work with while preparing this report. Let's start with chapter 1, which is on what we call software build quality, which is a bit of a big name for things like software maintainability, for architecture, for security, for sustainability, and various other topics that are relevant to keep your software future fit, let's say. In this chapter, we give you a few outlines because we're sort of taking all these systems together to give you an impression for where is the market going and how can we slice and dice the market to make it more specific to your case. Because there are various ways to do that. This is a new way that we've added this year to the benchmark. So we're really diving into it now, going into the details. Here we see a breakdown of our benchmark into life cycle phases. So basically, what is the age, what is the state that a software system is in? So we can look at software from initial development through evolution, where things are already in place but changing a bit, to maintenance and to decommissioning. This is a new factor we now have. Our clients can annotate this in their SIG grids to tell them this system is in this phase, and then we can make our benchmark more specific. An interesting metric here is growth of those systems. So for me personally, I've been doing some research on how software should behave normally, how it should evolve, how it should grow. And here are some numbers, averages, that describe how software grows. Keep in mind, about a 15% growth rate means your software doubles every 5 years, right? So these are interesting things to know because this has impact on the cost of maintaining these systems. Here are the KPIs that Bart was hinting at that reflect whether we are moving in the right direction to our mission of making software more healthy in general. And it's a subtle line. It's a subtle increase. We have to conclude that is ever so slowly going upwards. And what we do every year around this time is that we look back with our current quality model to all the years that went before. Normally, SIG recalibrates its quality models every year to keep fresh and to keep up to speed with the market. In this case, we've looked back with the latest version of this model to see the trend. Well, the impact of this increase here is that if you want to stay at the 3 stars or the 4-star level, you have to keep working, right? You have to keep improving. The market gets better, and so you should sort of put in the work to stay there. This is quite a big analysis based on 7,500 systems that we've measured over the past 3 years. And you see here our maintainability score, which is the average of all the others in the middle, the bluish line. And it goes up and down a bit because some systems, they come to us, some systems are out of scope, and that's how it evolves. So next year, we'll probably see the same trend, going up a bit higher again, and you have to keep working for the stars. Well, we've sliced also our benchmark based on industry sectors. So to give an impression of how our systems in government doing, for example, who are pretty solidly at 4th place, actually moved up 1 notch. They're typically in the middle, around the average. And you see here in this ranking also sort of where it gets to below average quality. So everything below 3 is below average quality. We have a newcomer this year, healthcare systems. We've collected enough data on that category to put them here too. Unfortunately, not above the bar. Well, the top 3 then, banking, industrial transport, and energy, oil, and gas. Typically the top 3 the last few years that we've seen. Now and then they change position a bit, but those are fairly stable there. Those are said. So another aspect here is technology stack. What we do, because we're comparing systems to everything else, but we're still interested in what are these systems like. What we do here, we check what a system is predominantly built in. And this year we've changed this benchmark quite a bit. So we're not comparing it to our previous years, but we're still presenting this list here. This is useful because maybe you're stuck with a system built in a database technology or a legacy 3GL, 4GL technology. Then you can see what the market typically achieves quality-wise. We don't think this should be an excuse to sort of also stay at 2-star level, but it might be wise to check what can be achieved with the language and maybe decide to phase out systems in such technologies. Here, low code is at number 3. They used to be at number 1 actually for the past few years. So low code technologies are well suited to build smaller systems and relatively quickly, with many of the quality indicators at a high value. But in our new benchmark, systems built predominantly in BPM or in web technologies are clearly of a higher quality. So next I'm going to talk a bit about this low-code technology. What we're seeing here, their average is pretty high and that's pretty good. However, we're seeing one thing we really want to sort of raise an alarm for is their architecture quality that we're observing. And another sort of foreshadowing here is that many of the AI big data systems that we're seeing in practice are in this very bottom category. Right, here is low code. A graph we'll use a bit, a style of graph, I have to say. So here on the x-axis, we're putting the size of systems. So the bigger they get, the more to the right. It's actually a logarithmic scale, so it gets big pretty quick. And we have one of the metrics we use for architecture called component entanglement. You could say spaghetti, not code, but spaghetti components, right? So at the high level, Here we see a big difference between modern general purpose languages like Java and C Sharp and Go and Rust and things that are sort of modern, and low code, which is modern, of course, but has a problem here. So if these systems get bigger, these are average lines, their quality on this aspect really drops pretty quick. We've done a lot of analysis with our teams on that, and why is it the case? And there are some pointers there. Platforms in low code can offer a lot more support for developers to be aware of this problem, that such spaghetti components can start to emerge, to alert them and to suggest improvements. And there's really a lot of improvement possible there that would make such low-code systems a lot more future fit. More in the report on that. Let's dive a bit more into architecture in general. So as Bart was saying, we have developed pretty recently an architecture quality model, which was soft launched, phased rollout since about Q4 of last year, where we do a better effort of measuring all the intrinsities of software quality, which is not a software architecture, I have to say, which is not a simple subject. We asked enterprise architects for their opinion on what would you need to modernize architecture in a survey, and the major outcomes there were surprisingly, actually, well, not surprisingly, first, coupling of the landscape, so systems working together and having to decouple them. But second and third, and together actually a big category, were more social factors. Like, do people know enough about the systems they have to change? Is the knowledge distributed well enough? Is the work distributed not too much, right? Is it not too scattered? So that was really an eye-opener for us, and that led to a architecture model that we have defined and described that takes these things into account. So the model works like our maintainability model. It breaks down the concept in a few others, and the 6 here are the main concepts that we measure again with 10 things we actually measure in the code. So there's things about structure, communication, data access, etc. When we do that, we have collected data since last year, and here you see a plot of what that looks like. Our worry was that these things would be highly correlated, so maintainability would be very similar to architecture quality, but it's not. These are orthogonal measures. So you can have high quality on architecture and low quality on maintainability. And in our opinion, that has an impact on how you should evolve your portfolio of software. If you have high quality in both, and then you're in the green, and you should probably try to stay there. But if you're in the right bottom corner, you have relatively high maintainable code, but with bad architecture. Re-architecting is maybe still possible there. And at the other side, maybe you should refactor your code within the architecture, etc. So this is a new dimension to looking at your portfolio. Moving on, this is also reflecting this survey that we did. What we did here is we measured what's the most impactful measurement in our architecture quality model. And it turns out to be this knowledge distribution, by far. Right? So the high performers, the good architecture quality systems, they really do well on this knowledge distribution angle. So that's where a lot of the focus should go. And then coupling and component freshness, which are more technical measures, they come really a far second and third. What does this model do? Right? We always want to investigate, okay, we have these stars, right? That's nice. We can now put systems apart. But does it mean anything? We are doing research. This is initial research. We have looked at 50 systems so far. Whether their issue resolution time, so the speed at which they resolve problems, is actually better with higher quality, with higher architecture quality. And that turns out to be the case, and quite a quite big difference so far. All right, let's talk about AI then. AI and big data systems, not that easy to define because a lot of people are doing things with AI. We are seeing lots of integrations of these things. Lots of customers are playing, or actually are beyond playing already. They are really integrating such things. Do we see a good level of engineering? Well, there was a bit of foreshadowing on this. Unfortunately, no. Right? We have to be clear about that. This is our benchmark. You see the red dots are the normal systems, let's say the not AI systems that we have in our benchmark, and the blue ones are those that do, that we have classified as AI or big data. We know a bit why this occurs. There are clear indicators that the units of code are too long or too complex, and we have some ideas on how to fix that. It's also good to say, and that is also something Bart mentioned, there are exceptions here, right? It's not impossible to build such systems with high quality. Unfortunately, we see a lot of, the majority, and actually the average here is 2.7 stars for AI systems. It's way below average. Something to be concerned about. This is an example of code that we see, which is typical SQL-like data processing code. It's not really, there's no abstraction. There's, you could say for a typical software engineer, an easy fix by using functions and abstraction to make this a lot better and more understandable. That's one of the patterns we see a lot that we could automate analysis for to help people. Another one is test code. So this is a problem that is quite severe. Testing AI code is not easy, but the same was said about normal code like 15 years ago. So we're now stuck with a test code ratio, which is what we measure. How much test code do you have? How much production code do you have? Of only 1.5%. And this is sort of where we're at 15, 20 years ago when unit testing started to become popular. We're at a median of 43% now in our benchmark. We want to go to 80 as a recommended average. So here AI is really lagging. You'll have problems with defects being harder to find or simply defects that occur in production. Open source is a problem that we spotted, or that the industry was spotting already a year ago, where we are seeing a lot of vulnerable code, vulnerable open source code being used inside enterprise software systems. And we raised the alarm last year because we really felt something needs to be done and still needs to be done, because there is now also legislation coming up, for example, from the EU on the Cyber Resiliency Act, or from the US. Software producers in particular, need to move to zero vulnerabilities. Are we there? No, we're not. This is the state at the moment. Every month we see how many systems that we see pass by in SIGRID are actually vulnerable. And so that is not, it's not a nice message. It's more than 50%. If you are a bit willing and optimistic, you can see that the line is going down, and it is. But still, the number of critical vulnerabilities, so these are classed as the highest problem by the international security community, is still very prevalent. And these are not hobby projects, right? These are actual customer systems that do something in their business. We made a top 3 of critically vulnerable libraries. These are very common packages used in Java. By the way, we're not saying don't use these things. We're saying be sure to have the latest version that is not vulnerable. But for example, we see vulnerable versions of these 3 occur in 10% or 8% of all systems we see come by. And that is a significant portion. We also made a split into business critical systems versus other systems, because we were expecting sort of business critical systems to do a lot better. Unfortunately, that's a very minor difference. It's still there, and here you can see, actually it's going down, right? The rate of vulnerability, and that's good. And actually, with our customers, we have started working when Log4Shell vulnerability happened in December 2021. We looked in all our systems and find out who has this and who do we need to call up. We think that made a difference. And in our symposium, we repeated the message last year, but we're not there yet. There's a very high chance there will be legislation that says You need to have 0 vulnerabilities in your software. One way to achieve that, well, there are many ways. This is one perspective where we see a clear correlation between the quality of these libraries and their build quality and the risk of such vulnerabilities being present. Here we have 4 stars as 100% risk, you could say. That's the baseline. And we have measured 50,000 Java and Python libraries to see if that makes a difference. And the difference is quite clear, that if you go to 3 stars or even 2-star level code, the risk doubles, or in some outliers even more. 5-star code is typically smaller and better quality code that has less than half of the risk. So something to really keep in mind. Right, our final topic on the skills, because we see all these things in software and people can do better and the code can be better. Ultimately, it's the people that need to do this. So together with Exin, our sister company, we are looking at how people are equipped for their jobs, right? If they're developers that need to implement these changes, have the right competencies. That's the goal of Astrid, the tool that people can freely use across the world and have done so, about 5,500 of them, to produce such overviews. You complete a questionnaire, which is not a small questionnaire, actually it's about 200 questions to get a pretty detailed impression of your competency level. And we project that against a framework of competencies and job roles. In this case, it's the European Competency Framework. Then you get a percentage score for how good you are, how competent you are for your current job. In this example, it's pretty dire, right? They're in apparently a CIO of 27% match, and they're a better match to others, right? So it's supposed to give also candidates the idea where they could move, right? What they are skilled to do. Here is the benchmark we have collected so far. On Astrid, you get a score of max 80 points. And you see here that the vast majority of the roles that we have in this system are actually less than 40, right? So that's less than half of the competencies that this job expects are actually present. That was quite a shock to us. That people are self-reporting on this, and still we're seeing not a great match of the skills to what they can actually do. There's some highlights here. For example, developer is quite low at 20. So we can also get from this data pretty quickly what are the most missing skills that people should train for. And these are the top 3: component integration, testing, document production. Relates to this architecture problem that we're seeing, where you want to document, you want to spread knowledge. Data scientists, on the other hand, you could say data scientists should be developers too, right? Because they need to produce high quality AI code. They are not so well equipped to do developer tasks. If you look at developers and what skill sets they have, data scientists are typically scoring lower on all of them. So that's a skill gap that you could try to address as well, if you want to have more future fit AI code. All right, these were the 5 topics of our benchmark report. I urge you to take these to heart. There are some pretty stern warnings here, in particular with respect to AI and vulnerable open source code where change really needs to happen. We're very concerned also about the skill gaps that we're seeing and ask organizations to see where training could be implemented. If this same skill gap, this is a global view that we're presenting today, maybe it's different in your organization, but there's a way to find out. Thanks a lot for your attention. We've decided actually that instead of sort of a Q&A now, we're going to provide to you the report, either, well, digital for sure, and then we'll send the fixed version of this somewhere next week. Invite you to read it, maybe at your sunbed on holiday or wherever you want. And on September the 14th, we're organizing an AMA session, which we can do online or physically. We didn't decide yet, to have a discussion about that, to have an open discussion and get your feedback then. Thank you.